Hey, everybody, this is Larry. This is day 5th. Oh, Cinco de Mayo, huh? Anyway, and I forgot yesterday was May 4th, may the 4th be with you. I don't know. I mean, I'm just a nerd, I guess. So I did forget it, so maybe not that much of one. But anyway, uh, how does it go? Feliz Cinco de Mayo, I guess. Uh, yeah, happy. I don't know if that's a real thing that people celebrate or it's just like one of those things that people do to get like I don't know, just like a thing. But yeah. Anyway, today's problem is let's get today's problem is implement stack using queues. Uh, I was gonna say it was like what you call it, uh, like a like a holiday they create to sell alcohol or something. But I don't know. Maybe it is. I feel like that's just like one of those things. But anyway, that's implement stack using queues. Let's focus on this. Welcome. If you're new here, uh, we'll be doing this all month, or these problems. I mean, we have a 760 something streak going, as you may discover. So I'm not going to break that today. And also, sometimes I have like a little reloggy update. Not much today. Except for what we were just talking about with Cinco de Mayo. So hope you find that amusing. If not, that's okay. Usually you could skip the beginning if that's what you're into. But hit the like button, hit the subscribe button, and come to Discord if you want to chat about anything like that. Anyway, okay, let's get to it. So you have a stack. Last and first, I'm using two queues. Oh, I have a funny thing about this. This was something that I was given this problem um, on an interview that I had in 2005, say. Wow, just saying that year out loud makes me like age myself. So I remember this problem, and I also remember it because I messed this up because at the time I just didn't. Well, I mean, just to be clear, there was no Leetcode and stuff like that, and I was very good. Even at the, I mean, maybe not very good, but like good enough in competitive programming per se that like at least at the job interview level, right? Like yeah, like the people that are really good. But I was just like merely really good, at least good enough to pass job interviews because they weren't really that popular at the time with respect to competitive programming problems, except for say Google or something like that. Um, so yeah, I got this problem not as a coding problem, but more of a brain teaser problem, and I didn't get it to be honest because this this type of problem doesn't really come up in competitive programming, right? It's about like problem solving and less about like data structures. I mean, I did get it, but at the very end, but it took way too long, and it was just a no bueno, I suppose. But yeah, so I do remember this very well, and it's kind of really like a cute idea. But I just speed myself up because like I said, it was like 17, 18 years ago, and I still remember it because I was like, Larry, you should have gotten it because I was doing something where like you have two queues, but you just keep on moving the items back and forth, and I wasn't able to prove, at least to myself at the time, because I don't know, I was just younger and maybe a little bit more nervous, during an interview. Like this idea that like it's that like this idea of invariance and how to kind of handle it. So yeah, but that's basically. Oh, actually, I think I lied to be honest. Now that I read this problem maybe correctly, I think my problem was implement queues using two stacks, where this one is using implement a stack using two queues. So okay, so I lied a little bit, but the idea is still the same. So hopefully you find the story interesting. Uh, and it still have the same premise that like it doesn't really come up. So let's think about what it means. And now it's funny because we see it and it's an easy problem, right? So we'll see how I will see if I actually solve it because it's still not the type of problem that comes in with competitive programming. Okay, so now you have two queues. You want to simulate a stack or implement a stack. Okay, so then now I guess for a stack the only, well, I was gonna say two operations, but I guess peak is an operation as well. So or I guess top and peak is like these two operations, but not really. The only two that I was thinking of is push and pop. So first of all, let's have just two queues. I imagine there's some way of putting them, but yeah, I mean, I don't think it's that bad. Basically, you just want to make sure the last number you're in is out. Okay, so let's just even write it out, just like Q1 self.Q2, right? And we'll use collections dot deck. Also, I see that sometimes people in my Discord channel, we share solutions just to kind of like get code reviews and feedback and stuff like that. Another reason why you should join. People definitely sometimes just like get a little bit like, I don't want to solve it this way. I'll just like, use a stack and then just literally do it. I mean, at the end of the day, these things are for you, right? Like the things that you challenge yourself, the time that you spend on these problems, exploring and discovering things, these are things that you're going to learn for later. And if you do a shortcut or like just to get a streak continued but not really learn anything and really didn't think it through, at the end of the day, only and it only matters to you. So it is what it is. There's no right wrong answer. And well, I mean, and you could reason, if you have to ask whether an interviewer is going to ask, you probably already know the answer for that one. So like prepare for it or whatever, but that's really up to you. Okay, so let's say we have push, right? So in this point, let's say we start with an empty state, right? So I'm just thinking about it, all the combinations one by one. So let's think about it from empty states. Well, there's only one thing you can do. I mean, and of course, there's some symmetry here, so it doesn't matter which one you append, right? And then now, let's say you append the second one, right? Well, what does that mean? Dun, dun, dun. Okay, so let's actually visualize this a little bit. I know the other solution, but I don't know. So let's say we have two queues. How do we put them in a good way? So let's say we add number 1, and then let's say now we add the number 2, right? How do we use the second, or do we use the second queue? Right? All right, let's say we have a number. Then we use the first queue, and then we use the second queue, right? I mean, in this case, it's going to be O of n, so I think, oh, wow, 1 queue. Huh. Well, I'm trying to think for a second, because I mean, on what I can do here, right? I mean, so the other solution, I would say that the other solution, the queue using 2 stacks, something that you do find out in computational theory, for example, is that it is Turing complete, so you could do everything. I'm actually not sure about 2 queues, so I'm not super sure here, but I would also say that I don't know if they want us to have a linear solution. That's why I'm like contemplating a bit, right? Because if we can have like an O of n solution for push and pop, like that also makes it kind of trivial. So I don't know if I can do this in O of 1. But let's play out with some ideas first. Let's say we put in the numbers 1 and 2. What is a possible way for us to do it, right? 1, 2. So the idea that I had that's O of n is that every time we add a number, we just kind of, can we do that? Let's say we have a 3, right? With 3, and then now 1, 2. Well, that's not. Well, okay, let's try it from the beginning. I think my states are weird. So let's say we have 2 queues. So the idea I have is that let's say we have 2, then now it's 2, and then now you take the 1 from the other one. So it looks like this. And then the other, let's say you added 3, so now you have a 3 here, and then now you have 2 and 1, right? So you have kind of like something like that, but this is going to be O of n every time because you have to get rid of the entire queue every time, right? So, and of course that's going to work because we have at most 100 cores, but I'm trying to think whether we can do better. And also whether I can do it with only 1 queue. Uh, doing it with one Q is interesting, isn't it? Well, I mean, doing it with one Q, if you can do O of n, is the same in that, yeah, you don't need this. You just, on insert, let's say you have one, and then now, let's say you have a two. Well, yeah, let's say you have a two, then you put this in one, two, and then you just keep on rotating the array essentially until it's two, one. And then next, now you have two, one. So then now you add three to the n, and then now you just keep on rotating. So now it's 3, 2, 1, right? Oops. So that's not that bad to use one queue. I'm just trying to think whether O of n is necessary and whether I can think of a constant solution for this one or a constant time solution for this one. Because otherwise, this is probably it. And pop is straightforward in that sense. I think the thing is that, and I'm also trying to think whether we can, I mean, this would be way pop optimized, but I was wondering if we can do some kind of delayed thing, and then maybe the amortization makes it O of 1, even though you do it, but I don't know, it's tough. These problems are tough for me because in many times, you know, like it's just about creative and using your tools, and versus like here, the key part of this is that it's restricting your tool in that, like, well, you have to implement a stack. Well, you just implement the stack the normal way, right? So obviously not the case here though. And these two are also input. So in this case, push is going to be O of n, and all these are going to be O of 1. Is that good enough? Can I do this in O of 1? This is also a little bit harder because I'm at home doing it by myself, right? Because obviously if I have an interviewer, I think this is something that we'll talk about, and then I could maybe see if I can figure out what the intended solution is, right? Like if I need to do better, then I need to do better. If not, then, you know, but, I don't know. And it is tricky that this only, like, if this was like, say, like a million calls would be made, then I'll be like, okay, O of n is not going to be fast enough, right? But the tricky part is that O of n is going to be fast enough. So that's why I'm like, is there a better solution? I don't know. Let me think. I mean, well, using one queue, I feel like the one queue is kind of a hint in that way, in that I don't think there is like, I don't think you could do an O of 1, otherwise you would just never have a stack. You just have one queue, right? So okay, fine. Let's try it this way, and then maybe we could see if we learn anything from, or maybe even past Larry. I don't know if I've submitted this problem before. So yeah. So basically, let's say okay, n is equal to length of self.q. So then now what we want to do is self.q.append x, and remember that n is the last number. So then now we do something like this, where x is equal to self.q.pop left, and then self.q.append x. Maybe I'll use y in this case because, yeah. And you could technically put in one line, but yeah, that's what I do. And then pop is just self.q.pop left, and then return it. Top is return self.q.0. Don't know if I'm supposed to return, like if this is empty, maybe for an exception. This throws an exception, but in theory, you're supposed to recast the exception in a more understandable kind of way, but whatever. It's fine for now. All right, let's see. I mean, this is going to be right, I think, other than maybe off by 1, which is possible. This should be right. Yeah, let's give it some minute. I should probably test more cases because it's very typoable. But yeah, 765 days. So yay. Yeah, like I said, I think the difficult part for me in this one is just not knowing whether this is optimal. And very often these things are kind of tricky to prove optimality. Let me see if I could create solutions and see. Yeah, that's basically what I did, except for I did it with one queue. Okay, same thing, but with one queue. Okay, I mean, this is just different operations. Okay, so it seems like this is the intended solution, and we spent a lot of time talking about it because I wasn't sure if this is the intended solution. Um, and the reason is because, like I said, on a real interview, you'll probably like suss it out, and but in here, like I am talking to myself. I know that you're watching, and it seems like I'm talking to you, and I'm trying to, but I cannot read your mind, or maybe but okay. I mean, yeah. Mm, wait, there is a maybe over one amortization. That's what I was saying. That's what I wondered. Yeah, that's what I thought. I mean, now I'm reading solution comments, but I mean, I think this isn't that bad to be honest. Like, I think Yeezy is probably the. I'm just reading the comments. I think Yeezy is probably the okay like classification. I think the tricky part comes from not knowing how fast you want push, right? Because we knew then we got it pretty quickly. If we, if we like, I was trying earnestly for a while to see if I could have an all of one, either amortized or not amortized, but I couldn't really figure it out. And also, like I said, if you could do a one queue all of one solution, then you wouldn't need stack as a data structure. You just use a queue every time, right? So I feel like that was my thing to say, like, that doesn't really make sense. And that's why they're two different things, right? So yeah. Anyway, that's all I have for today. Let me know what you think. Hit the like button, hit the subscribe. Wait, I did submit it, correct, right? I want to make sure because sometimes I forget and then I miss the day. Anyway, that's all I have then. Hit the like button, hit the subscribe button. Join me on Discord. I'll see you later. Take care and goodbye. Ta-da.